Today's assignment is going to be a little different from your previous assignments. So let me show you how to find this on Canvas. I'm on my Algebra 2 page and I go to Assignments. And you, of course, are going to look for Assignment 1.6, Graph Lines Using Tables. And then today's assignment is not a Canvas quiz. Canvas will not grade your assignment. You're actually going to go to a website, GeoGebra. Click on this link and it'll take you to GeoGebra. Now, when you type your name in, make sure you type in a name that I can grade you by. Make sure you put in your first name and last name so I know who to grade. Don't put a nickname or something I wouldn't recognize you by, because this is the name I'm going to use to grade you. But when you start this activity on GeoGebra, you're going to see it starts with a couple of examples. And we're going to go ahead and do the first two examples together on this video, and then you'll have the rest of the assignment to finish on your own. So example number 1 says, graph y equals 1/2 x plus 5 by completing the following table. And you see this little XY table right here. Now the first thing you need to know, you will need a separate sheet of paper to work this out on. Absolutely positively, get out a separate sheet of paper. It can be scrap paper, but you're going to need a piece of paper to write down your answers before you can start typing this online. So we've been studying relations, functions, domain, and range. Well, one way to write a function is like this, as an equation, where you have a y on the left-hand side of the equal sign and an x on the right-hand side of the equal sign, and then we're able to study this relationship of how does the x values affect your y values. Now look at our table. In our table, in the first row of our table, we're given this input of 4, of x is equal to 4. Well, with any function, as long as you're given an input, you should be able to find the output that goes with it. In this case, it's actually pretty easy. If we simply plug 4 in for x and do 1/2 times 4 plus 5, you can even just get out your calculator and do this, you get an output of 7. So that means we're going to write a 7 into the y column of that first row. If we have an input of 4, if we have an x value of 4, the corresponding y value is a 7. Now let's continue that again into the second row. What if we have an x value or an input of 6? Same thing, we can simply put a 6 in place of the x, do 1/2 times 6 plus 5. It ends up being 3 plus 5, which is 8. And this is called the corresponding y value. We would say that when the x has a value of 6, that the corresponding y value is an 8. Now the third and fourth rows get a little bit trickier. Let me change colors here. So in the third row, they give us this y value of 1. In this case, we would actually have to put a 1 in place of the y value. And we're going to have to solve for x. So here's a case where we need our algebra skills. We need to be able to work backwards. If I'm going to solve for x, I'd have to subtract the 5 away from both sides. And 1 minus 5 is -4. And then I have to divide both sides of this equation by the fraction 1/2. Now, -4 divided by 1/2, when you divide a number by a fraction like 1/2, that number is actually going to grow. If you don't believe me, put it in your calculator to check it out. When we take -4 divided by 1/2, we get, the number doubles. It becomes -8. So here, when I'm giving this y value of 1, I can say that the corresponding x value is -8. Now in this case, I have to work backwards to get there. Same thing with the last row. When I have this y value of 0, I can plug 0 in for y, and I'm going to have to work backwards to find out what the x would be. I'm going to subtract 5 from both sides. 0 minus 5 is -5. Divide both sides by this fraction of 1/2. And when you divide a number by 1/2, that number actually doubles. I get an x value of -10. So again, completing this table, this is something you are going to have to do on a separate sheet of paper. But here we go. Here's what my table looks like. Now, once I've completed this table on a separate sheet of paper, well, let's start to graph it now. So task 1 says plot all 4 points on provided graph and connect your points with a line. So here's the GeoGebra app. To add points, I'm going to click on this icon, this point icon, and let's look back at my values again. I had the points 4, 7, and 6, 8. Well, the first point is called your x-coordinate. I'm going to go to 4. So for 4, 7, I'm going to go to 4 on my x-coordinate and 7 on my y-coordinate, and I'm going to click my mouse. Here I am putting a point at 4, 7. The next point, if you check back to your table, is 6, 8. So I'm going to go to 6 is my x-coordinate. This is this horizontal axis is called my x-axis. So I go to 6 on the x-axis. This vertical axis here is called my y-axis. I'm going to go to 8 on my y-axis, and boom, there's my point 6, 8. Likewise, my last 2 points were -8, 1 and -10, 0. Those points would be -8, 1, -10, 0. Here is what the 4 points from my table look like on a graph. Now, the last thing I want to do, so what I've done with my table has shown 4 of the solutions to this function. This table shows 4 of the answers to this function, but in reality, this function has an infinite number of answers. And so what I can do back to my graph is now I can click on this line icon. I can click any 2 of my points, it doesn't matter which ones, and GeoGebra is going to draw a line connecting all 4 of the points. Now what this line represents, this line actually represents all of the infinitely many points that could possibly fall on my original function. Okay, so let's scroll down. Let me shrink my screen a little bit. Let's scroll down to task 2 here. Which of the following points is also on the line y equals 1/2 x plus 5? Is it 2, 6, 0, -5, or 3, -4? Well, let's look. 0, -5, 3, -4. That is a mistake. Oh, no, wait. Now I see it. It's going to be 2, 6, and here's why. At first, I didn't think any of those were on the line. But 2, 6. If I just kind of trace now an x value of 2, a y value of 6, you can see right here the point 2, 6 is on that line. So I know just by looking at my graph that 2, 6 is also a solution to this function. So the correct answer, 2, 6. Now let's scroll down to example number 2. Now example number 2 is the exact same idea, but your equation is written in a little bit trickier format. This is called the standard form of a linear function. 2x plus 5y equals 15. So I'm still going to graph it the same way by completing this table, but let's get out our scrap sheet of paper. And this table is going to be a little bit trickier to solve, but let's break down exactly how we're going to do it. So in example number 2, the idea is still the same. I'm going to take, in the first row, I'm going to take this x value of 0, and I'm going to plug it into the equation. I'm going to write 2 times 0 plus 5y equals 15. And I need to find the y value that corresponds with an x value of 0. So here I'm going to have to use my algebra skills. 2 times 0 is 0. And so to solve for y, I'm going to subtract 0 from both sides of the equation, divide both sides by 5, and I get a y value of 3. When x is equal to 0, y is equal to 3. And I'm going to kind of fast forward on the second row. Whoops. So I've already worked out the second row. If you plug an x value of 2 into the equation, you get a corresponding y value of 2.2. So that point has been plotted. That row of the table has been completed as well. Let's move to the third row. Now what if we have a y value of 2? In this case, I'm going to have to plug a 2 in as a y value. I'm going to write 2x plus 5 times 2 is equal to 15. And I'm going to have to use my algebra skills. 5 times 2 is 10. So to solve for x, I'm going to subtract 10 from both sides. And 15 minus 10 is 5. And divide both sides by 2. X is equal to 2.5. I can add that to my table. When y is 2, we have a corresponding x value of 2.5. Let's fast forward for the fourth row. So likewise, when I plug a 0 in for y, I get this x value of 7.5. All right, let's take this to our graph then. So I've completed this table on a separate sheet of paper. Now let's plot all 4 points. Okay, I'm going to click on this little point icon, and let's look at my first 2 points. I had 0, 3 and 2, 2.2. 0, 3. Now 2, 2.2, I'm going to have to estimate as best as I can. I'm going to estimate right about there. If you ever make a mistake, you can click on this arrow and kind of drag this around wherever you see fit. But just estimate as best as you can. And then my last 2 points, 2.5, 2, 7.5, 0, 2.5, make sure I'm on my point icon, 2.5, 2. Oh, where'd you go? Try that again. All right, there it was. Here's my 2.5, 2. It's a little tricky because they're so close together. But there we go. And then 7.5, 0. These are the 4 points I was able to match on my table. I was able to find on my table. But now I'm going to connect. Here I'm going to just connect the first point and my last point. And maybe I'm even going to go back and adjust this point B a little bit. There we go. So my table only showed me 4 of the solutions to this linear function. And it's called a linear function because the graph makes a straight line. You can see by the points. But my graph, when I connect these points with a line, this line shows me all of the solutions to this linear function. So task 4, which of the following points is also on the line? 2x plus 5y equals 15. So it's not 2, 5. That'd be too high. It's not 0, 5. I'm guessing it's this negative 5, 5. Let's double check. If I go to negative 5, 5, you can see how that falls perfectly on the line. So I know that negative 5, 5 is also a point. So the bottom line is, you have 3 of these to try on your own now. Problem number 1, very simple to example number 1. You'll need to, on a separate sheet of paper, work out this table, plot your 4 points, connect them with a line, and then answer the multiple choice question that goes with it. Problem number 2 is going to be very simple to example number 2. Same idea for you to try on your own. And then problem number 3, also very similar to example number 2. Find these 4 points, plot them, connect them with a line. Now, last thing I want to point out to you, when you're done, remember this will be graded for accuracy. Make sure GeoGebra has this little note here, all changes saved. This will let you know that GeoGebra has saved all of your work and it's ready to be graded. And then here's how you actually submit. Once you've finished and you see this all changes saved, you'll X out of GeoGebra, go back to Canvas where it says submit assignment, and all you're going to submit is just type me a little note letting me know that you are finished. You can say, I'm finished. This is basically how you send a message to me, let me know that it's ready to be graded, hit submit. Now, Canvas will not grade this automatically. You'll have to wait for me to go in and grade it by hand. But that is how you will know. That's how I'll know that it's ready to be graded, and then I'll go in and I'll grade it by hand. So best of luck on this assignment. Let me know if you need any help.